Let's get started. Hi, my name is Marit van Dijk. This is my first NDC. Thanks for having me. And I'm here to talk to you about reading code. Fair warning, I'm a developer advocate at JetBrains, and I'm a Java champion. So I use mostly Java and other JVM languages, and the code examples will be in Java. I'm just telling you now, because I have had the feedback like, this was a good talk, but all the code was in Java. So if Java is very upsetting for you and you want to leave, that's totally fine with me. Just don't give me a bad review at the end because of it. Thank you. Is anyone here a Java developer? A few, okay. So we are outnumbered. The rest is .NET developers? Okay, so the brackets are going to be in the right place. And the interfaces will not be starting with an I. I think that's the differences, right? So, shots fired. Anyway, so we spend more time reading code than we do writing code. Most of our tasks involve reading code of some sort when we're adding features or fixing bugs, when we're trying to understand a new system that we might need to work on, when we're doing code reviews, when we're learning about new technologies and reading books or blog posts or watching videos. All of that involves reading code. In fact, developers on average spend as much as 58% of their time comprehending existing source code. That is a quote based on research from the book The Programmer's Brain by Feline Hermans. I highly recommend this book. I don't get a commission. Feline Hermans is a professor of computer science education at Vrije Universiteit Amsterdam. And she wrote this book called The Programmer's Brain with a subtitle, What Every Programmer Should Know About Cognition. So we spend more time reading code than we do writing code, but we don't practice reading code, or we hardly ever practice reading code explicitly. And even if we do talk about readability, it's often about writing readable code. So we're still not actually reading the code, we're just discussing what makes code more readable. There's a lot of research in Feline's book on that as well, rather than books that have lots of opinions on what makes readable code that we won't mention. So Feline is also a conference speaker, and she gave a talk in 2019 at Strange Loop called How to Teach Programming and Other Things. That's literally her research domain. And in this talk, she mentions research from 1992, which is before I learned programming. Did anybody learn programming before 1992? Some of you, okay, cool. So anyway, in 1992, there was some research where they had a classroom of students who were learning programming concepts. They split the classroom into 3 groups. The first group would write and read code. The second group would write and read code, but the code that they were reading actually had explanations about that code, like what choices were made, why certain implementations were chosen, etc. And the third group would only read the code with those explanations. And what they found in this research was that actually the second and third group were better able to reproduce the programming concepts that they were learning over the first group that wrote code and read code without explanations. But we mostly learn programming by writing lots of code, right? And we still do that. So after that talk, someone came up to Feline and said, but what if we did practice reading code explicitly? And that's how Code Reading Club was born. So they started an experimental club thinking, how can we deliberately practice reading code the way that we practice writing code with code katas? And I will share a link to my website at the end that has all of these links for my slides, etc. But do feel free to take pictures in the meantime. So I heard or read about Code Reading Club somewhere, and I was like, that sounds really cool, I want to do that. And I got really lucky because a friend of mine actually reached out and said, hey, we're starting a Code Reading Club, do you want to join? I'm like, yeah, I do. So we've been having a Code Reading Club for about 2 years with monthly sessions. Not everyone is able to join every time. Some of us travel for work. But we've been doing it for 2 years, and I found it really helpful, and that's why I want to share that experience with you. So in the Code Reading Club, we take a printed sample of code of maybe 1 or 2 pages, which is harder to find than you might think, a sample of code that's not too long but still has something going on. And we apply structured exercises to that code. You can also do it electronically. There's an annotation tool that you can use, but I actually prefer to do it on paper. Use some colored markers. As adults, we don't get to play with colored markers enough, so that's an added bonus. And the screenshot that I have here is actually the result of one of our sessions. And I think that this is actually C# from this session, but I'm not sure. You can tell me better than I know. So just to give you some examples of the exercises that we do, we usually start with an exercise called First Glance. That's literally what it is. We take 1 minute, we look at the code, and we write down the first thing that we notice about the code and why. And that's already an interesting exercise because we have a very diverse group of people. We all live in different countries, England, Netherlands, Germany, US even. We work in different roles, from developer advocate to developers, testers, quality coaches, and we all work with different languages, Java, C#, JavaScript, Ruby. So we all have really different experience. And we work in different industries, of course. So when we do the first glance exercise, it's really interesting to see that different people notice completely different things about a piece of code. Some people might say, oh, I noticed this, and that's a familiar term, so that gives me a hint of what this is about. Someone else might say, this syntax right here is completely foreign to me. I have no idea what's going on, and I want to understand that before I try to make sense of the rest. Next, we might identify components and relationships between them in the code, which is interesting if you're reading a foreign language or an unfamiliar language, that you can still find the variables and the methods, etc., even if the syntax might be different. We also do an exercise where we identify the 5 most important lines in this piece of code. And that, again, is very interesting, especially if you don't agree upfront what most important means, because different people will select completely different lines. Someone might select, these are the 5 lines that help me understand what this code is about, like a class name or a comment or a method name. I mentioned we have testers and quality coaches in our group. They might notice, these are the lines where decisions are made and I need lots of test cases, so these are the most important lines to me. Someone might say, okay, these 5 lines determine the control flow through the code, so those are the most important lines to me. So if you do this exercise, either see what happens and what people think is most important and why, or see if you can agree with your group what most important means. Because we found out over time that we actually ended up converging on most important lines. So in the beginning we had really different results, and then over time, as we had this club every month, we ended up agreeing on what most important lines were. We might identify concepts that the code deals with. And usually there would be people like, I have no idea what this means, and there would always be someone in the group who can then explain that to the rest. And it's always someone else. So it's not like, oh, this person knows way more than the other. We're all learning from each other. And then finally, even though we didn't maybe look at the meaning of the code and what it was about, we'll take 5 minutes to summarize what we think the code does to our best approximation, and usually are able to pretty well describe what the code is actually about. Sometimes people would bring their own code so that at least we could explain at the end what the code was about. Sometimes we use code that we find on the internet, in which case it's harder to be sure that you know what the code is about. That's also not really the point of the Code Reading Club, although I've also given Code Reading Club workshops at conferences and meetups, and there are always some people who really want to know what this code is about. Despite that, that's not the point of the exercise. The point is to practice how we can get there. But some of us really, really need to know the answer, apparently. So again, I really enjoy Code Reading Club, and I really highly recommend trying that out. Not just because it allows you to practice the skill of reading code and get better at that, but as I mentioned, I really enjoy getting other people's perspectives and learning how they see the same code completely differently, or I might ignore part of the code as, oh, that's not important to help me understand what it means, and someone else might be completely fixated on that, like I need to know what that means and why. That's really interesting to me. And finally, as part of that whole exercise, you also have to make your own assumptions explicit, so you're more aware of what you're thinking as you're reading the code, and that can also be helpful. I wrote a blog post about that if you want to go read that, but again, I'll share a link at the end. The thing that I really, really also like about Code Reading Club is that we are practicing reading code not to judge the code, but to understand the code. So, quick question, who's ever looked at a piece of code and thought, this is utter garbage? And the rest of you are too afraid to put up your hands then, or? Okay. So, counterpoint, who writes bad code on purpose? A few of us. Okay, as a developer advocate, I write bad code so that I can fix it. But most of us did not put our hand up. So the next time you see a piece of code and you think, this is garbage, whoever wrote that, and that includes past you, because I have seen code that I wrote 6 months ago where I'm like, apparently I learned a lot in 6 months, so now I can do a better job, yay. We don't set out to write bad code. So have a little bit of empathy for the circumstances under which the code was written. We all know that we have deadlines. We might have had a bad night's sleep. We might not understand the domain properly yet, and we are learning as we go. So the Code Reading Club also helps you practice a little bit of empathy that I think we can use in the world today. Gestures broadly at everything. So in Felina's book, she discusses reasons why code might be confusing. And she talks about a lack of knowledge, a lack of information, and a lack of processing power in the brain. These are tied to our cognitive processes. So knowledge is the information that, or the knowledge that we have stored in our long-term memory, the things that we know. Short-term memory is the information that we have available to us right now. And the working memory is how we process all of that information. A lack of knowledge might be either in the programming domain, it might be an unfamiliar language or syntax, or programming constructs, algorithms, design patterns that you're not familiar with, or it might be in the business domain, domain concepts or business logic that you don't know or don't know yet. Maybe you just switched to a different team, a different industry, a different company, and you need to learn all of these things. We can deal with a lack of knowledge, of course, by doing some research, and Felina actually recommends that you make a list of the things that you don't know, so that you can also sort of keep track of your research, because who's ever been like, oh, I don't know what that means, let me go find that out, and then you go down a bunch of rabbit holes? Yes? Okay, not just me. So, if you make a list of the things that you want to research, you can keep yourself kind of on track. And if there are things that you actually need to know a lot of the time, then maybe memorize some of that information. I know that we can go look up the syntax of whatever, or any information that we need. If you need that a lot, just memorize it. It's going to save you time. A lack of information can be different things. It can be unknown details. Maybe the code is using a library method that you don't know the exact implementation of. There could be unfamiliar names, especially if the domain is, for example, new to you, or a pattern that you're not familiar with. Code can be connected in unknown ways that you might not find out until you run the test and something over there breaks, even though your change is over here. So now you learn something about the system. Or there can be too many things going on at once. If you're processing lots of data and doing lots of transformations to it, it might be hard to keep track of everything that's going on in your brain. We can deal with a lack of information by chunking information together. Who's ever heard that you can keep 7 plus or minus 2 things in your short-term memory? Okay, some of you. Turns out it's actually less. It's 2 to 6 things. So if you can group information together, you can keep more information in your short-term memory. If you can recognize, oh, this is a pattern, rather than all of the elements, separate elements that make up that pattern, you can chunk it and keep more information in your short-term memory. So learning concepts and patterns is helpful. A lack of processing power in the brain can occur if there are too many processing steps or too many variables to keep track of. And we can deal with that by offloading some of that and using memory aids, for example, a dependency graph or a state table. A dependency graph might look like this if you do it on a piece of paper. So you might mark stuff and see how it's used throughout the code. This is an example that I literally took from the Code Reading Club website. So for the person in the audience who's wondering where this code came from, I have no idea, I'm sorry. So this is a way that we can create a dependency graph to help us visualize how the code or how the control flow works. If you have lots of variables to keep track of, we could use a state table. This is a very basic nested loop in Java. I'm sure it looks almost similar in C#. Obviously, this is a fairly trivial example. I'm sure you have examples in your code that are way more complicated. But if you need to track the state of the variables, a state table can be helpful. So Felina was writing another book called Code Reading in Practice. Unfortunately, she put that on hold because she has too many great ideas that she's working on. So she's going to do other awesome stuff, I'm sure. But unfortunately, this book is on hold. I did manage to read it when it was early release on O'Reilly, so I can share some of it with you. In this book, she was looking at different dimensions of code reading: structure, domain, concepts, and context. So in terms of structure, code is not read linearly. We don't read it from top to bottom. We don't run it from top to bottom either. In terms of domain, the code deals with behavior and data. In terms of concepts, we've discussed, we have programming concepts and domain concepts. And we have context. The application doesn't exist in a vacuum. It has users. It might talk to other applications. There might have been a reason why we created this application originally. Those reasons may have changed or no longer be valid. So it helps to have a little bit of context of why that application came to be and how it came to be, because you can't capture all of that in the code. Obviously, we read code mostly in our IDEs. So we're going to look at how an IDE can help you. I'm going to use my favorite IDE, which is IntelliJ IDEA, for obvious reasons. I work for JetBrains, they do pay me. So a lot of the features will be similar. Does anyone use Rider? Few of you, okay. So a lot of the features will be similar in Rider, and they might also be available in other IDEs, but slightly different, and code editors. So there are times when we need to understand a new code base. For example, if we're joining a new team or a new organization, or if we inherit a new code base or want to contribute to either a shared code base or an open source project. And we have to quickly figure out what's going on and what does the code actually do. It can help if there's someone who can give you some of that context. Before I joined JetBrains 2.5 years ago, I worked at an online retail platform in the Netherlands. I was on 3 different teams during that time. One team I was on the longest. When we had new people join our team, we would give them an overview. We were in charge of multiple microservices. We would give them for each microservice an overview of this is what this application is about. These are the other applications that it talks to. Just a high-level idea of the application. And that makes it then easier to open up the project and know what to do. So if you have new people joining your team, I highly recommend doing that. Or if you're joining a new team, ask that they can do that for you. Obviously, also depending on the size of the project. The last team that I joined, they had one project that was so small I could just open it up, kind of read through it. I'm like, okay, that's clear. Am I correct that this is how it works? Yes, okay, cool, let's go. If it's bigger and more complex, then get some context. So obviously, at some point, you're going to check out the code. Also, if there's no one to give you the context, you're going to check out the code and try to figure it out for yourself. And here, the IDE can help you. So I promised you there would be Java code, so sorry. I'm going to use the Spring Pet Clinic as an example of the Java developers who uses Spring. All of one, hello. Okay, so the .NET equivalent of Spring is ASP.NET, is that it? Like it's a dependency framework? dependency injection. Anyway, so not the point. So if we're trying to figure out what this application does, we can look at the project tool window and just look at the structure of the project. So we can see what packages we have and what classes are there. And we see that some are more in the programming domain and some are more in the business domain. So we have owners and pets, and we have vets as well, because it's a pet clinic. So that gives us a bit of an idea of what we're dealing with in this application. After I check out a project, I also like to make sure that I can actually build it. Please tell me that it works today, or I can't type. Yes. So I like to make sure that I can actually build the project and run the tests before I make any changes, because if I make my changes and the project is broken, I know that it was my changes that broke it, rather than having to figure out whether it was my changes or it was already broken. Ask me how I know. So making sure that you can build the project so that you can verify that you didn't break the project after you make your changes. It's going to take a little while and hopefully get to build success. If you can't build the project in whatever standard way that you're used to building projects, see if there is information in the README on how to build the project. This is the Spring demo project, so obviously they put a lot of information in the project on how to build and run the project. That isn't always the case. I have worked on teams where the README was literally, this is the repo for this project. Super useful, thanks. And that team had different microservices, and each was built in a different way. So some were using Jetty, some were using Netty, some were using Spring, some were using Spring Boot. I don't know if you have that many options in C#, but imagine every project builds in a different way, and you have to remember, I'm getting older, I cannot. So one of the first things that I did is in each README, okay, this project, build it like this, run the test like this, da-da-da-da. So if your READMEs are like this, first of all, why? And second of all, please write down how to build your project, what you need. Your future self and future team members will thank you. So in the meantime, oh God, what now? Okay. Of course, my demo project is broken. Docker is fighting me. I have to go complain to my Docker friends. Oh, we do have build success. Never mind. So anyway, we can build the project. Another thing that you might want to do is to run the project so you can actually use it locally. Praying that that works now. So you can look at the project and see how it works and interact with it. And that will also help you after you make your changes to the project so you can actually test them out. You do that, right? People test their code. I know Stacy does. She talked about it yesterday. Also, puppy and kitten tags. So we can use the application locally and interact with it and kind of get a feel for what it does. This is a fairly small application, so we can find owners and veterinarians. And they even put a helpful error endpoint here. So if you want to know what it's like if a Spring application throws an error, you can find that out. And if your application is throwing an error, you can use AI Assistant to actually explain that runtime error to you. And I'm going to show you a few AI assistant features as well, because I actually really, really like the AI assistant features for working with code and understanding code. I know that it can write code for me, which is nice, but I actually like writing the code. What I struggle with more often is understanding code that someone else wrote and someone else includes past me. So things like this that can help explain what's going on are super helpful. So in this case, the error is intentional, and AI Assistant usually figures that out. Like 9 out of 10 times it'll say this error is there intentionally, but it will still tell you how to get rid of the error if that's what you want. So finally, if you're more of a visual person, diagrams might help you. So you can use your IDE to generate diagrams for you. If it's a small application like Pet Clinic, the UML class diagram might actually fit on one page. If it's a huge project, it definitely won't. And you might have to zoom in at different components or search it or whatever. And using generated diagrams or provided diagrams is nice because it gives you a quick overview. However, it is actually recommended that you draw your own for 2 reasons. One, if you have a bigger application, you might not need the entire diagram of everything. You might only, for whatever use case you're working on, need a part of it. So you can draw a diagram with just the view that you need for whatever you're working on. But also, research shows that if you draw your own diagrams, you're actively engaging with the material, you're better able to remember that information in the future over just looking at a diagram. But being able to generate them does give you some information already. So that's nice. We have an idea of what Spring Pet Clinic does. We might feel comfortable making changes to it now. But what if we have a project that is way bigger? Can you read this in the back somewhat, or not really? I could zoom a little bit more. Ooh, okay. But then my next feature doesn't really work on Zoom. So actually, sorry. When we go to the actual code, next demo, we'll zoom in more so you can actually read it. Because I just want to give you an overview of a different type of feature. So as you can see here, even without being able to read the module names, we have a bunch of different modules. So now if we want to get an idea of this project, we might want to figure out, okay, what module do we even get started with? How are they all connected? I happen to know for this project that most of the individual modules have a README that explain what that module is about, so we could read all of those. But even if we want to get started, which would be the best module to get started with? The fact that there's one called Core might be a hint. That might be a good place to start, but we might also want to visualize that. So we can actually visualize that in a matrix. This feature, by the way, for the writer users, I'm sorry, is only available in IntelliJ IDEA. And if your IDE doesn't have it available, you might want to create your own. You can look at all, or in this case, the POM XMLs that describe the dependencies and generate your own diagram of how stuff is connected, but it helps if you can visualize it. So for those of you who can't read in the back, we have the same module names here in the rows. Obviously, the columns, because it's a matrix, are also the same modules, but we don't show the names to make sure that it fits on the page or on the screen. The modules are sorted differently. They're no longer sorted alphabetically as they are in the project tool window, but they are sorted by usages. So the modules that are used by other modules are sorted towards the bottom, and the modules that are using them are sorted towards the top. And we can see in the legend that the blue boxes are the dependencies between the modules. If there were any cyclic dependencies, so module A depends on B and B depends on A, they would be marked in red. That's not good. You want to pull that apart. So that's another use case that you could use this for. And we can see the direction of the dependencies. So a green module uses a yellow module, and we can see that if we click on them. So if we, for example, click one, we can see that Cucumber JUnit in this case uses the Cucumber core dependency, and we can figure out how all of these directions go, and we can click individual ones and see which ones are used and which ones it uses. So that gives you kind of an idea, and then also gives you an idea where you might want to look further. We discussed AI Assistant quickly. Oh, wait, sorry. I want to show you also that we can generate different kinds of diagrams. So we saw an UML diagram with classes. We can also generate a project module diagram, which gives us one side of this equation. So this module uses these modules. Finally, we might ask AI Assistant, for example, can you explain this project to me? For Spring Pet Clinic, it can, because it's part of its training data. It knows that it's, oh, the file currently doesn't work. Try with the README. So it does take the open file into account. Sometimes it takes a while. So in this case, it knows that this is, or well, it doesn't know it's AI. It has as part of its training data the Spring Pet Clinic, so it's able to explain that to me. If I ask the same question in Cucumber JVM, which is the implementation of a behavior-driven development framework, that is a less standard application, so it's not able to quickly figure that out. You might need to give it additional hints because it also has Spring in there somewhere. So we'll try to explain that that is also a Spring application, which is actually not correct. So then you might have to feed it more information to get a proper answer. Okay. So there are lots of ways that our IDE can help us if we're trying to make sense of a new project, like looking at the project structure, building and running it, looking at the README to figure out how to run it. I also sometimes look at the dependencies to see what libraries are used, whether those are libraries that I'm already familiar with, or if I'm not, I add them to my list of things that I might want to research, at least do a quick search of what even is this library so that I know, and then depending on how important it is for the project, learn more about that particular dependency, and of course we can use diagrams. And outside of our IDE, it also helps to identify components and relationships and dependencies between them, identify concepts that we're dealing with, maybe research the ones that we don't know about, and gain context of the application of all of the things that we can't capture in the code from hopefully your teammates or people who have worked on this project in the past. Another way to familiarize ourselves with an application is by looking at a particular slice of an application. We don't always need to know the entire code base to do whatever task we're working on. We might only need to know a little bit. For that, we might want to find a starting point, which can be either generic if we do want to understand more about the application as a whole, or it can be very specific if we're working on a specific task. So a generic start point might be a main method or an endpoint. Is it also a main method in C#? Is it called main? I honestly don't know. Ish? Ish. Okay.
Depends if you're using top-level statements or not.
Depends on if you're using top-level statements or not. Okay. Someone explain that to me later. Or endpoints, or if you're looking at something specific, maybe an error message that you see in your logs or an exception that is thrown that you need to understand where it's coming from, or specific logic or functionality that you need to work on or make changes to. So obviously, again, your IDE can help you because it makes it easier to search and navigate a project. So, for example, we can search for the main method in our Spring Pet Clinic application. This is where, for the Spring developer who will know this is where the Spring magic starts, so it's actually not a very useful place to go and navigate to because, well, unless you want to figure out how Spring works and run it through the debugger, this won't tell you much, but if you have a different type of application, you can go to main and then see what that calls and figure out how the application works. For this particular Spring type of Spring application, it might be more useful to, for example, look at an endpoint. So we can look for a controller class. Oh, wait. and see what kind of endpoints we have and see how that works. We can navigate from there to, let's see, we save something at some point, I'm sure. So we can navigate from there to our repository layer. This is a fairly small application. If you have a bigger application, there might be a service layer in between. So you might navigate like outside in all the way down to your database and back up again to figure out how one particular endpoint works. We can also look at the endpoints tab to get an overview of your endpoints. For Java, we also have OpenAPI or Swagger. I don't know if you use that as well. So if your application has that, you can look at the Swagger page and get an idea of the endpoints, what entities there are, what fields there are, etc. You can also add documentation to your OpenAPI to describe all of the fields and get some documentation on how that works. And you can work your way outside in to understand the application. If you're looking for something specific, you might need to look for example, where a particular error is being logged. You can go find that in your application. Then you have to figure out, okay, where actually in my application am I? So you get a bit of context. So basically, this is the "you are here" of your code base. You can figure out where in the application you are and basically trace your way back up. How did we get to this error? What might I need to change to fix it? And being familiar with searching and navigating in your editor or IDE makes it easier to perform your tasks. So make sure that you're familiar with these things. We can also ask AI Assistant for help. Let me start a new chat. And I saved the prompt to save myself some typing. So we can, for example, ask, where do I find the SQL to find the owner details? And the AI Assistant will call back to the IDE and actually go find that for us. So we can also interact with our code that way. Okay, from this it doesn't. Try again. Of course, if I do it by myself, it works. And if people are watching, it doesn't work. Thanks, Demo Gods. Super appreciate it. But actually, I have chat history. Or I should have chat history. Where is my chat history? Anyway, so normally it finds it. Now, today, it doesn't. I'm sorry. So other ways that we can search and navigate our application is by looking at recent files, which might be helpful if you're working on something and you want to navigate between the files that you're working on. We can look at recent locations that I can't figure out the shortcut for right now. So recent locations, so actual places in the code. If your classes are very long, maybe jumping to the file doesn't help, but jumping to the actual location where you were might be more useful. So that's a way that we can navigate. And also we can put bookmarks in our code. So if we're tracing, for example, a certain call stack and we want to be able to trace that back, we can put bookmarks in our code and navigate to those. And we can also give them names, or rather letters and numbers. So, for example, we put 2 bookmarks and then we can navigate between those bookmarks and trace a call stack. So that can be useful. I also use bookmarks, for example, if I'm working on a particular story. So I have a use case that I need to either add functionality or fix a bug. But usually I find some stuff that I also want to fix, but not necessarily as part of this commit. I'm forever the person on the team who notices all the typos, and I think I'm the only one. But I want to fix them, and I want to go back and fix them, but my team doesn't want me to fix them as part of this story. So I bookmark them, and then in the end, I get to fix all the typos, and it makes me happy. So, you know, that's at least one of us. So that's another useful way to use that. So searching and navigating is super useful. That's also why we check out the project if we want to try and figure it out, so that we can use searching and navigating and all of the other functions of our IDE or code editor, rather than look at different files on GitHub. So strategies outside of your IDE might be to look at a particular use case, draw some diagrams, draw your own so that it helps you think and you can draw them for the thing that you're actually trying to focus on. But finally, we might have a piece of code that we really need to understand because a bug is hiding there, or we need to make changes to that piece of code. Have you ever seen a piece of code and been completely overwhelmed and have no idea where to even get started? Yes, okay. So now you have structured exercises that give you something to do. Even if you just use the first glance and just look at the code and find the first thing that you notice, anything at all, gives you a place to get started, and it gets you past that overwhelm. But obviously, your IDE can help you. So let's zoom some more. Can you read it now? In the back? Yes, no? Yes, okay, thank you. So when we're reading our code in the IDE, obviously we get syntax highlighting, so it will tell us what annotations we have, keywords, variables, etc., that we don't have if we're reading text in a book. We have lots of additional hints for the OneSpring developer in the audience that we can provide in gutter icons. We have inlay hints to give you, for example, the type of the expression. And we also have ways to pull up additional information, because we know that one of the reasons code can be confusing is because we lack information. So if we didn't have this inlay hint of the type, we can actually, if we know the right shortcut, pull up type information. And get what type a particular expression is. We can also pull up quick documentation, which in this case isn't very useful because there isn't any Java doc for this class. So if we go here, we can add some documentation. And then we can pull up that class with the documentation. So we can pull up documentation for classes or methods that we need. And we can also pull up the definition of that class. So we don't have to navigate our big project and possibly get lost. We can pull up the information that we need right there. We mentioned that we don't read code from top to bottom, but we look at the structure of the code. So we can actually collapse our code so that we only see the methods, so that we can focus on a bigger picture rather than be overwhelmed with all of the details. I know that this is a feature that VS Code also has. It's the only one that I know it has of all of the ones that I showed you. I don't use it. So we can collapse the code, look at the structure, and then find the pieces that we need. Actually, the more experienced developers are, the more they scan the code looking for the parts that they need instead of reading all of the details. And I also know people who, by default, collapse all of their code and only expand it as needed. Even if it is collapsed, we can still search the code, and the relevant parts will expand. So in this case, if I'm looking for payment, this will expand. And if I look for payment info, then a different part will expand. And then we can, of course, expand the parts as we need them. There are other ways that we can pull up the structure. So there's a structure tool window that we can pull up and get the structure of the class. We can use that for navigation as well. And we have, if you prefer to have it off to the side, we can open a structure tab. For the OneSpring developer in the room, we recently added a logical view, which tells you more relevant information for your Spring Beans, etc. but we also have still the physical view, which is similar to the structure, file structure that we can pull up. Obviously, we might want to look at, did I change something somewhere? Okay, so we might want to figure out the behavior of this code, and hopefully there will be tests. So we can navigate to the tests to look at what tests there are, and again, hopefully also those tests will describe the intended behavior of your application. Multiple reasons I would recommend highly to describe the intended behavior of your application in the names of your tests. As you're writing the tests, you're thinking about the intended behavior. If you can write that in a brief description of your test, the odds of you building the right thing increase. Second, that gives you runnable documentation. If those tests pass, you know your code does what those tests say it does. That's an added benefit. Third, if they ever fail in the future and they have a clear description of what is supposed to happen, that is going to save you time figuring out what went wrong. So you're working on a change, some random test fails somewhere. Now you have to figure out why. Did I break something that I shouldn't have broken? Or did I forget about some piece of functionality that I also have to change as part of this change that I'm working on? So literally no downsides to giving your tests good names. You all write tests, right? Just checking. Yes, okay. It really should go without saying that you give them proper naming. However, I have looked at codebases and found tests that were literally called test scenario 1, test scenario 2, and I tweeted about it at the time, and 2 random friends replied with, "But are you now sad 1 or sad 2?" And I'm like, yes, I am. So please, for your future self, give them proper naming. So I should have already placed a breakpoint somewhere. Yes, I did. So if we want to actually observe that what we think the code does is actually what the code does, we can run it through the debugger. So we can debug a test. If there isn't a test exercising the piece of code that you want to exercise, maybe add one, or run your application through the debugger and then wait for it to hit the breakpoint, which might be more difficult and require some effort on your part. So if we hit the breakpoint, then we can see in the editor, we get all kinds of information about the state of our variables and objects. We can look at the call stack. We can look at, again, the state of our variables and objects in the debug tool window, expand all of that. We can step into a line if we want to, or step over. I'm now going where I don't want to be, never mind. So we can, if we want to go to the method that is actually called in a line, then we can step into it, or we can step over it depending on where we want to go. The more experienced you are, the better you'll get at placing the breakpoint at the right place. One feature that I also really like is that I'm able to evaluate expressions. I know that we said we can already see the state of our variables and objects both in the editor and in the debug tool window, but we can also evaluate them, and this is actually also an editor, so we can also evaluate different types of expressions. So we can get the order ID, but we can also, let's say we are trying to figure out why it doesn't match something, we can figure out, hey, does it match this thing? No, actually it doesn't. So if we're trying to fix a bug, we can also try some stuff out until we get the right thing. Now we know how to fix it, and then we can go fix it and kill our bugs. So that's one of my favorite debugging features. We have way, way, way more. So I do recommend familiarizing yourself with the debugger. It's going to make your life way easier, and you don't want to learn how to use the debugger when you're also trying to urgently fix a production incident. So take some time to familiarize yourself with the debugger. You'll be very, very happy that you did. when you need it. Obviously, we said we are reading the code to try and make sense of it and understand the code. We're not trying to judge the code, but sometimes it does actually help to kind of play with the code as we are trying to read it and understand it. And so we can also refactor the code a little bit to verify our understanding. Hey, if I change this, does it still work? Or hey, if I change this, does it actually break? So some of the things that we can do is, for example, as our understanding of the code grows, change the names to match our current understanding. So for example, within the context of a customer order, item is actually an order item. We can change the name for a second if that helps us to make sense of the code. We can always roll it back. And we can also, let's say we have a very long method or lots of things going on, we can extract methods. So in this case, in certain cases, we want to cancel the order item. We can extract this method, give it a meaningful name, or if you have a really long method, extract certain parts, give them meaningful names to give you an overview of what's actually going on. And then also we can either inline variables if we no longer need them explicitly, or extract variables and give them a meaningful name to help show our current understanding of the code. Obviously, we can roll all of that back when we are done. Also, we can use AI Assistant to explain code to us. I already said these are my favorite AI Assistant features. So we can, for example, ask AI Assistant, explain this code to me, and it will open a new chat window and explain what that code is doing. So that can help, obviously, verify that it's correct. It is an LLM, but it can help you to understand the code. While we're on the subject of regex, who likes writing regex? Okay, so for the rest of us, thank you for always being people in the audience that oblige me with this. So for the rest of us, we can also ask AI Assistant to, wait, I need to first mark it as a regex. So if I mark this as a regex, and I open the AI actions, it will actually explain this regex fragment to me. We can do the same for SQL and for cron expressions and other, so you don't have to go to cron guru to get an explanation for your cron expression. You can ask AI Assistant in your IDE, which is useful. And also, we have a feature, this is not AI, just to show you some features that we've had for ages. You can check a regular expression so that you can check whether a certain string actually matches the regex. So once it matches, it gets a little green check mark. If it doesn't match, it will tell you as well. So that can be useful as well. So lots of features that your IDE has that can help you understand your code. Finally, you might want to do what I call a little bit of Git archaeology. Maybe you look at the code and it's not the way that you remember, or you want to figure out, hey, when was this changed? Why was it changed? We can look at the history in Git and look at a specific commit. So in this case, I added exception handling at some point. Obviously, we can look at the diff and see what changed in the code. But also, this is where an LLM can be useful. We can ask to explain a commit. If it's a small commit, going through the diff won't be that much trouble. If it's a huge commit, getting an explanation from an AI assistant to get a summary of what happened might be useful. And then if we need to look at the details, we can still go into the diff. So lots of ways that both the IDE and an AI assistant or coding assistant can help you. By looking at the structure, using the hints from your IDE, looking at tests if you have any, or adding tests if there aren't any, running them through the debugger, playing with the code, restructuring, refactoring for understanding, and throw that away. Looking at the context, the Git history, and using AI assistant features if you have one. Also, for the regex folks, my friend would like to remind you that the plural of regex is regrets. So if you're confronted with a piece of code that you need to make sense of, you can apply structured exercises, you can use memory aids like dependency graphs and state tables, and you can gain context about that piece of code. Maybe there's external documentation, maybe your teammates can help you figure it out, but otherwise there's lots of things that you can do in the IDE to help you figure it out. So what might be next? If you are interested in doing code reading exercises, there are several resources that you can use. You can go to the Code Reading Club website. They used to have online events. They haven't in a while, but they might start up again. And otherwise, they have links to a Discord server if you want to talk to them or talk to them about your own club. And they have resources on GitHub for at least 3 sessions. If you want to try this out with your team or some colleagues or some developer friends, they have enough for at least 3 sessions with a code sample, exercises that you can apply to that, and notes for a facilitator on how to facilitate the sessions. And if you can't find people to host these sessions or do these sessions with you, then Felina's book also has lots of exercises that you can try by yourself, that you can apply to your code base at work or your hobby project or an open source project you want to try and understand. So if you just want to get a feel for those types of exercises. Or you can use those in your code reading club as well. So obviously let your tools help you, but don't forget to use your brain and accommodate for how your brain works. And as promised, here's a link to my website with recordings of previous versions of this talk, slides, and other links to relevant materials. Thank you. If there are any questions, I'm okay with that. Otherwise, I'm going to go grab lunch and find me. I will be heading off to the airport in a little bit. But you can also find all of my socials on my website and contact me there.